Alright, so the first problem I wanted to look at to review is dealing with basic set theory. This is one of the key ideas to the unit, and you can see here that there's a lot of details. So when you go through this, we got to be careful. We got to pay attention to all the symbols, and we got to use proper set notation, something that I see a lot of people don't do when they should. So in the problem, we're given some sets. We're given the universal set, and then we're given three other sets, A, B, and C. All right. So for the universal set, the way you read that is the universal set is the numbers that are less than or equal to 10. And then it says X is natural numbers. Now what natural numbers are 1, 2, 3, 4, 5, 6, so on. Basically the positive numbers. So what we're going to do is we're going to start plugging in numbers into X from 1, and we're going to stop at 10. Okay? So remember this is called set builder notation. I know this kind of messes people up, so it's good practice here. So I'm going to start with 1. We're going to plug 1 in for X. Then we're going to plug in 2 for X. That's the next natural number. 3, 4, 5, 6, 7, 8, 9, 10. And I know that's a bit small. I normally like to shoot tutorial videos with the HD camera, but the drama department's using it right now, so I've Jimmy rigged up my smartphone to record this. Alright, so again, universal set is, you got to be careful. It tells us in the problem that this is the universal set. This set takes care of all the other sets. So my sets A, B, and C, whatever other sets I define, including their complements, they have to sit in this. This is your universe. It's the universal set. Alright, so first A. The way you read that is we are going to put values in for X that are natural numbers. Okay? But in this case, the expression is 2X. So basically, first you put in the number 1 into 2X. 2 times 1 is 2. So the first element in A is actually 2. Now if you plug the number 2 into 2X, you're going to get 4. Okay? And you're going to keep plugging these numbers in as long as X is less than or equal to 10. Okay? So with this expression, basically, we're plugging in any numbers into 2X as long as the value is less than 10. So you plug 3 in, 2 times 3 is 6. You plug 4 in, 8. You plug 5 in, you get 10. But you plug 6 in and you get 12. So that's too far. So this set basically terminates at 10. Next is set B. B is the same format. You can see there that it says you're using the variable X. That's what the first symbol means there. The 3X means we're going to plug in natural numbers into X now, but we're going to multiply them by 3. So again, put a 1 in for X. 3 times 1 is 3. Put a 2 in for X. 3 times 2 is 6. Put a 3 in for X. 3 times 3 is 9. 4 in for X is 12. But again, it says there it has to be less than or equal to 10. 12 is greater than 10, so we can't use that. So the set ends at 9. The last one, C, this time you're multiplying X by 4, or the natural number you put in by 4. So for C, you put in 1, you get 4. You put 2 in, 2 times 4 is 8. You put 3 in, you get 12. Again, 12 is outside of our universal set. We don't use it. So now that we've got our sets defined with just numbers, we've kind of gone past the set builder notation. Now we're ready to answer questions. So first, for A, it wants us to show that C is a subset of A using a Venn diagram. And again, if you see this symbol, C with the sideways U and then the A, that means subset. So it means that whatever this is has to fit inside this. And sometimes that's not true. If there's a slash through it, it means it's not true. If you look at this, though, 4 and 8 are also in this set, right? A has 4 and 8. So it means that this is basically a smaller piece of this. Again, I gave the example in class that there's subsets in real life all the time, right? Girls are a group that are a subset of our class. Boys are a subset of our class, right? They're a smaller group within the larger group. So here, this is true, and we need to show it using a Venn diagram. All we do is we draw a circle that is the bigger set, A, because the first one is within the second one. So C has to be smaller than A. You can see it is. It's only got 2 elements. This one's got 4 elements. So then I'm going to draw set C in here. C is going to be a smaller set. I'm going to label it C. And then we're just going to put our elements in. Well, C has 4 and 8. And again, there's little dots beside them. I told you guys if there's a dot beside them, it means they're elements. And I know that's probably hard to see. Unfortunately, I probably should have drawn this bigger. If 4 and 8 are inside C, then the other elements left are 2, 6, and 10. So there should be a 2 somewhere outside, 6 somewhere outside, and a 10 somewhere outside. That's showing that those 3 elements are in A. 4 and 8 are in A as well. But for C, C is only 4 and 8. Okay? So we've actually represented now C is a subset of A using a Venn diagram. So we've done that one. Next, let's do B. B says we need to represent A, B. It wants this. Okay? You need to know your connecting words on your formula sheet. This means or, so it's A or B. Okay? You got to use proper set notation, so you got to have your proper brackets first. Basically, this means anything in A or anything in B or anything in both. So first, 2 is in both. Or sorry, 2 is not in both. But 2 is in A, so we're good. See how 3 is in B? Well, that's got to be part of the list. It's anything in either group. It's or. 4 is in A, so we're going to count that. 6 is in both. Doesn't matter. Don't count it twice, but we count it. 8, 9, and 10. Basically anything in either group, but you don't ever count it twice. That's what or means. So again, know that this upwards U is or. Next they want the N, so this means, all this means is the number of elements in this. Well, how many elements are in here? Remember, each one of these entries is an element. 1, 2, 3, 4, 5, 6, 7. There are 7 elements in the union of A or B, right? Remember, union is or. Next, it wanted us to find A and C. So you got to know that this means and. The fancy word for that is an intersection. So the intersection of A and C. So intersection only means, this is different. With intersection, it means elements that are in both. So the overlap. So if you go back to A and C, what elements are in both sets only? Well, 4 and 8 are the only elements that are in both sets. So that's your intersection. So it's 4 and 8. It's only the overlap. Next, once the number of elements there, again, you have to know what this means, and then it's really easy. But if you don't know what that is asking, well then it's impossible. So you have to memorize it. NAC means, all right, how many elements? The number of elements in this intersection. Count them up. There's 2. That's it. Done. Last one. This one is using, again, some notation that you need to know. This is A or B or C with brackets and then a little tick at the top. You really need to know what that tick means. It means complement. It basically means not. The opposite, it means this or this or this, opposite of that. Okay? So this basically means the opposite of anything in the brackets. So first what we want to do is, we want to find this stuff inside first and then just take the opposite of that. So what's A or B or C? We'll go back to your lists. This, A or B or C, without the tick, is just going to be anything in the sets A, B, or C. So I'll start at the bottom. We got 2, 3, 4, 6, 8, 9, and 10. So basically, where is our overlap? We have some overlap on these, but we're not concerned with that here. It's or. It's basically any of the elements in these 3 sets. Okay? Now that you've got that, we got to now take care of the tick. The tick says, all right, take this and take everything that is not in there. So what numbers are missing from there? Well, the numbers that are missing are, we got the number missing 1, 5, 7, okay. And any other numbers missing? No. Yeah. 1, 5, 7. Yes, Finley, we're learning about math here. My son's just coming, and he's very interested with my jimmy-rigged phone thing here. All right, so 1, 5, and 7 are the elements that are not in this union here. Okay, so that's the answer to C. Yeah, so this is an example then of a problem where we are taking into account the basics of set theory, specifically set builder notation, which messes people up. So make sure you memorize what you need to know. So memorize those terms, memorize the symbols, and after that, you can see it's pretty easy. You just got to take your time.